So hopefully you made it through that first portion of Module 10 and didn't have too many questions about those acid-base reactions. First we talked about how you determine what's an acid and what's a base by looking at it. Really you're determining which one is giving that H plus, that extra proton, and which one's accepting it. Okay, acids donate, bases accept. Okay, and then we took that and we said, okay, how can we predict a balanced chemical equation based off of our one acid that we know and our one base? So real quick before we hop into molarity, I'm going to show you the list that I forgot to show you last time. This will help. And this is already in your book. I just broke it down so it's a little bit easier to see. Okay. So this is just the steps you would take on determining an acid-base reaction. Okay. So first you would recognize what's the acid and what's the base. So you're looking for what's the H plus, what's the OH negative. Okay. Once you do that, you're going to break the base into its ions. So you're going to put that line and break it. And then you're going to find what ion is left behind. I'm going to show you this in just a second. And then you determine the chemical formula from the resulting compound. So that's when you cross things over. Okay? And then I said, don't forget to balance your reaction. Okay? So I'm going to show you these steps really quick. So if I have, let me grab, so let's say I have HF plus KOH. Do I want to use that one? Yeah, I can. Oh, we won't get there quite yet. Okay, so let's say I have this, and they say determine the acid-base reaction and give me the balanced equation. These are just the steps that you already did. Okay, number one is just recognizing which one's the acid and which one's the base. I see the H is here, so this is the acid. I see the OH is here, this is the base. That's step one. Okay. Then it says break the base into its ions. Okay. I'm just going to show you that with a line. You don't have to actually break it down and write all the ions. We can see that this is going to be one of them, OH is going to be the next. Okay. Step 3 says determine what ion is left behind after the H is donated. So this is the same thing. I'm going to break this, and this is going to be the ion left behind. Okay. So I'm going to leave what's left behind and write it over here. Okay. So this is step 4 now. It says determine the chemical formula for the resulting ionic compound. So this is what we learned in Module 8. So I look to see what my charges are on this. This is going to be a -1, and this is going to be a +1, okay? Because they're the same, we don't have any charge, so they just come together, okay? Now, if they were different, let's say this was a 2, that's where we would cross them. This is step 4. This is how we determine what this is to stick here, okay? So once we do that, we can put it here, and then we know what the last part is. We know it's going to be water, because that's our formula, okay? And last step, it's not the last step, but it's the little thing. Don't forget to balance your equation. So once you have it out here, don't forget to balance it. So let's walk through that one more time. You recognize which is the acid, which is the base. And then you split the base, so you can see where the 2 ions are going to be. And then over here on the acid, we're going to split the acid to see what's left over. We're going to take what's left over off to the side, and if we need to, cross them, okay, because we're going to find what that is. Once we find it, we stick it here, we add our water, because that's what we get when we add these 2 together, and then we balance our equation, okay? So, I just wanted to show you this. If you need to, I can send you a picture of this. I can send you a picture of all my little things that I've had up on the board until now. Okay, so let's hop forward. We don't have too much left with this module, but we are going to be talking about, hold on, we're on page 334. We're going to talk about molarity, okay? Oh, we're back to moles. I told you moles are so important with stoichiometry back from module 6, and here we are again. We're going to continue to use them because they're so helpful to chemists. Because remember, moles, we're able to look at moles And it's a way to compare one substance to another substance. It's the only way we can do it. We can't do it in grams because it's not the same, okay? Moles is a good comparison unit. So, we're going to talk about molarity. Molarity is, when you hear molarity, you should think concentration, okay? Concentration. So, I don't know if you, when you were kids, if your mom ever made you juice, but a lot of times you'll see juice concentrate. Okay? You might see it in the freezer section. And you get those the little jars of juice. Well, what do you have to do? You can't just drink it as is. It would be really gross, right? You take it out, put it in a pitcher, and you add water to it. Because when you buy it, it's concentrated. That means that it needs to be diluted before it's able to have to be drunk. Okay, so keep in mind as we're talking about this, that's what that means. Molarity just tells you how concentrated something is. Okay, so let's look at the definition. It says a concentration unit that tells how many moles of a substance are in a liter of solution. It's determined by taking the number of moles of a substance and dividing by the number of liters. Okay, molarity is a capital M. Okay, so in this last part of the module, I'm going to give you 3 little formulas that are going to help you remember. Okay, you're just going to be using them interchangeably. So let's look at the first one. This is what molarity means. Molarity, which is how concentrated something is simply